Okay, so 3D shapes, a lot of this just requires you to visualize 3D shapes. Okay, so it says that this is a cuboid, find the length of AC. Okay, I'm going to highlight this a bit. Oh no, my pen, no more ink. Okay, where is AC? AC is here. Okay, so we're looking at a right angle triangle here. Okay, so yeah, so we can just use Pythagoras to figure it out. So AC is just 16 square plus 12 square rooted. Okay, yeah, just use calculator. I think this one's 20. Yeah, it's 20. Okay, next I want to find AG. AG is here. Okay, and we're looking at this triangle here. Okay, we already figured out AC is 20. So again, we can use Pythagoras to figure out AG. Okay, so AG is 7 square plus 20 square rooted. I think this one's irrational. 7 square plus 20 square rooted. Yeah, it's irrational, so I'm just gonna leave it to 3 sig fix. Okay, finally to find angle GAC, here we just use basic trigonometry. Let me get my other color. So GAC is here. Okay, and I look at the red color triangle. I have opposite, I have adjacent. So I use tangent. Okay, so tangent angle GAC equals opposite 7 over adjacent 20. Okay, 19.3 degrees. Okay, give you a while to copy this.
Okay.
Okay, so VABCD is a right rectangular pyramid. Find AX. Oops, why is my pen not working? Hang on. Oh, okay, very good. Okay, find AX. Where's AX? AX is here. So I'm just gonna highlight the triangle that we should be looking at. AX is here. So we should be looking at this one. Triangle VAX. Okay, triangle VAX is a right angle triangle actually. So here's my right angle. Okay, now how do I find AX? Oh wait, actually this triangle doesn't help. I should be looking at the other one. Another one here. Okay. Okay, so this is my 90 degrees. So I can find AC first. Okay, so AC is 15 square plus 8 square rooted. Okay, this is 17 if I remember correctly. 15 square plus 8 square. Yeah, it's a Pythagorean triplet. Okay, so it's 17 cm. AX is half of AC. Okay, the reason is because the diagonals of a rectangle will bisect each other. So if you recall, right, this one you learned a long time ago. A diagonals in a rectangle, they will bisect each other.
Okay.
Okay.
Yes.
Okay, then for VX, okay, VX, I should be looking at this triangle here. VX, 1. Okay. Okay, 2, 3. Yeah, the challenge is it's always picking up the right triangle to look at. Okay, right angle here. So this side is 16. I already found out XC is 8.5. This one's 8.5.
Yes.
Okay, so VX, just be careful. VX is not the hypotenuse. So VX is 16 square minus 8.5 square is minus because VX is not your hypotenuse. It's one of the lengths.
Okay.
Square root is 13.6. Okay, and also try to make sense of your answer. Okay, so your height of the pyramid shouldn't be longer than the slant height. Yeah. Okay, finally VAX, angle VAX. observe the angle VAX. Let me get the color. This angle is actually the same as this angle here, because these two triangles are actually congruent. This one and the yellow color one. Pink and the yellow triangle are congruent. Okay, so to find VAX, I can find VCX first. And I can use any function I want. I'll just use cosine. So cosine angle VCX is 8.5 over 60. So angle VCX is 8.5 over 60. Cosine inverse, 57.9 degrees. Okay, and then I know that angle VAX is the same as well. It's 57.9.
Okay.
Okay, diagram shows a wedge. The rectangular base ABCD rests on level ground and is perpendicular to CEFD. Okay, it just says that this plane here is perpendicular. Oops. This plane here is perpendicular to this plane here. Okay. Okay, dimensions are given, angles are given. Find BE. Wait, I think I'm missing some information here. I don't have BE. Okay, so I look at this triangle here. Okay, this is 90 degrees. This is 90 degrees minus 38, which is 52. Okay, so I can use sine to find BE. Okay, so sine 52 equals BE over 52. Oh, same angle. The angle is the same with the length. Interesting. Okay, so BE, I can show you this key calculator, 41.0 cm. Okay, next EC. Now, sometimes it's a bit hard to visualize this triangle here. Now, for me to minimize careless mistakes, I'll just redraw the triangle in 2D. Okay, so BCB. Okay, this is 25 degrees. Okay, I know BE is 41 really, 41.0 cm. Okay, I want to find EC. I can use sine again. So sine 25 equals EC over 41.0. Okay, and EC is 17.3. Okay, finally, to find angle AEC, you get AEC is here. AEC. Okay, so this is 90 degrees. Again, to minimize my careless mistake, I'll just redraw my triangle. Okay, AEC. So I know EC is 17.3. AE given is 52. Okay, I want to find this angle here. So I can use sine again, or sine. Okay, so sine angle AEC, my bad. AEC is here. So it's not sine, it's cosine. So cosine angle AEC is 17.3 over 52. 70.5. Okay, so my only advice is if you want to be clearer, draw out the triangle.
Okay.
I'll give you a while to copy this down. Oops. Okay, 64 says what? The diagram shows a flower bed ABCD. BD is a pebbled path. Wow. Pebbled path, pebbled path, pebbled path. Okay. BD is a pebble path, so this is a path. Angles are given, dimensions are given. Okay, find angle BCD. BCD is here. Okay, so you look at this triangle, same thing, you see three sides. 1, 2, 3. You want to find an angle, use the cosine rule. Okay, so just write out the formula. 115 squared equals 135 square plus 56 square minus 2 times 135 times 56. Shut up. 56 cosine angle BCD. Okay, not enough space lah, but your worksheet is way bigger than my space. Okay, IG, you write this, right? 1 mark. Okay, and then optionally, because I've seen the mark scheme, if you write this, okay, if you write this, write this whole step, you get either 1 or 2 marks. Okay, but you see, so far I've always skipped this step. Why? Because I a bit overconfident. Okay, but IG is like that. If you get your answer correctly and you have some form of working, you still get full marks. You can skip steps. Okay, so I'm just telling you, if you write this, you get marks if your answer is wrong. Okay, but you shouldn't get your answers wrong. Okay, so let me key this in my calculator. Divide -2 times 135 times 56 cosine inverse. So angle BCD is 57.4. Okay, then part B, given that the area of triangle ABD is 2070, ABD is here. Okay, I need to overlap a bit. Find the length of AB. So remember the sine rule we did last chapter. Okay, so I have 2 sides here, and sandwich between these 2 sides is 30 degrees. Okay, so the sine rule is half AB times 115 sine 30 degrees equals 2070. Okay, again, just key calculator in. So AB is 2070 times 2 divided 115 divide sine 30, 72 meters. Okay. Again, you might want to write out your working. Again, it's up to you. So your working should look like this. AB is 2070 times 2 over 115 sine 30. Okay, let's move on. Part C. A kite is at E, which is vertically above B. Okay, now I need to remove some stuff first.
Wait, I haven't written it down.
Oh, no, okay. Then you copy first. You haven't copied anything yet, right?
I've done some of it.
Okay, I'll let you copy first.
Okay.
Okay, let me remove some stuff. Okay, a kite is at E, which is 25 meters above B. Okay, so I'll just put it here. This is E. Calculate the angle of depression of A from E. So it's around here. Okay, so a bit hard to visualize. So in this case, I will draw the new triangle here. So the triangle is here, is EAB. So EAB. Okay, and this is 25. AB is, we have found AB, that is 72 meters. Okay, find the angle of depression of A from E. So angle of depression is here. This angle here. Okay, then we can use alternate angles. it will be the same angle as here. Okay, so this red color angle I can figure out using tangent. So tangent angle EAB is 25/72. Okay, then just tangent inverse to figure out the angle. 19.1.